Welcome to ClickMyProject.com. There is the heterogeneous domain adaptation for the IoT intrusion detection and geometric graph alignment approach. This is our abstract. When it comes to IoT intrusion detection, data scarcity makes the data dependent algorithms less useful. In order to tackle this issue, we employ the data rich network intrusion detection domain to provide the enhanced intrusion detection precision for the IoT domains. In order to improve the transfer of the incursion information, this paper uses the geometric graph alignment technique to hide the geometric heterogeneities between the domains. In particular, each intrusion domain is expressed as a graph with vertices denoting intrusion categories and edge representing the category-wise interrelationships. A confused discriminator that is unable to recognize adjacency matrices between various intrusion domain graphs maintain the overall shape. In this paper, try to find the normal and anonymous data by using the KDD-cup 99 dataset and pre-process it and extract the feature, and then they are implementing machine learning algorithms and our propose this RF algorithm and give the high accuracy and prediction. This is our objective: to determine the abnormalities in the system telemetry. It is essential to train the models on data, which includes the benic and relevant attack behavior, to implement the pre-processing and data splitting of the raw data, to implement the machine learning algorithms such as RF for better performance, to enhance the performance analysis accuracy calculation, to enhance the performance of overall prediction result. This is our flow diagram. From the start, we want to load data set and pre-process it and split the data, extract the features. In the data splitting, we have to split it into train and evaluation data. After the data splitting, apply the classification, SVM, RF and DT. Finally, performance analysis, that is report generation. This is system architecture. We use the KDD-cup dataset and input data and pre-process it by the label encoding and the handling missing values, and then feature selection, data splitting, classification. Use the ML algorithms, SVM, RF and DT, result generation. Use case diagram. From the system, we want to interact with the user get the input data, pre-processing and then feature extraction and data splitting, classification and performance analysis. And then this is an activity diagram. From start point is input data, pre-processing, select the important features and split the data and classification and then performance analysis. This is sequence diagram. Data selection and loading, data pre-processing, feature selection and data splitting and classification. We are executing our code. This is our console output. We have the first, this is our data set. This is a data set sample and this is a data set description. This is a pre-processing stages and this is the label counting, and this is a how many normals and normally direction in this. After the training and testing splitting, we have to apply the algorithms in decision tree. First one is the accuracy, so confusion matrix and classification input, and then this is a confusion matrix in the SNS heat map format, and then a random forest and then SVM, and then this is the comparison for all these three.